In this video, I'm going to show how to create a class diagram for an Android application that uses a lot of common tools that we see today, including Jetpack Compose, Model View ViewModel with live data, Firebase, which integrates with that ViewModel, Room database, Retrofit, and several others. I'm going to use Draw.io as my tool to create this class diagram. So first, let me start with an explanation. A quick explanation of what we're going to take a look at, and after that we'll jump right into a live demonstration. First, when we're thinking about organizing our program, we want to think about dividing up our classes and interfaces into logical packages. And the structure I lay out here is fairly typical. There can be some variation on this, but this is fairly typical. So usually we'll have a root package, and then we'll have a DTO or data transfer object package, user interface package, service, and DAO. We'll take a look at each of those in the following slides. So the default package, many times this is simply the domain name in reverse. And we want a package to be unique. So that's why we tend to use domain name in reverse. MyPlantDiary.com is a domain name that I own, so com.myplantdiary is unique to something that I would create. If I have multiple apps, I might want to add more packages after com.myplantdiary, like maybe an admin app versus a user app. It might be com.myplantdiary.admin, something of that nature, but nonetheless, this is what it's going to look like. We don't want to put too much stuff in this default package. Here I have app module, which is used for Koin, and retrofit client instance, which is used for retrofit. We don't want to mix other things like user interface and DTO here. We want to keep this one fairly small. Next one, UI package. This is where we're going to do things like have an activity. And in the land of Jetpack Compose, we're not going to need a whole lot of activities. We need minimal activities because that user interface is dynamic. We're also going to have our view models, which provide live data to our user interface. And also the view models are a good integration point for Firebase. Firebase is a cloud storage engine that also synchronizes data across multiple devices. Very good tool to use to get an Android app or an iOS app or even a web app up very quickly with cloud persistence and synchronization. Very handy for that. DTO package. DTOs tend to be nouns. They're things that we're going to transfer across different layers. So when we're thinking DTO, we really want to think attributes. We don't need to think as much about methods because DTOs are really simply describing nouns. Service. Service is where we have business logic. So business logic is a bit of a tricky concept that I'm going to talk about in just a few more moments, but it's essentially things like buy one, get one free, limit 4, the customer buys 7, which ones does the customer get free? So that's business logic. Also video games, a lot of business logic in that. The service layer sits between the persistence layer and the UI layer. It's not persistence, it's not UI, it's the layer between those two. Many times we'll define interfaces in the service layer so that we can create just a hard-coded stub implementation of that interface while we're working on the actual live implementation. And that allows our partners who are doing the user interface and doing the DAO layer to continue to work against this hard-coded stub while we are working in parallel on the actual business logic implementation. The DAO package is for persistence, and we're going to do two different types of persistence in our application. The plant DAO is a retrofit interface, and retrofit allows us to fetch JSON data from the internet, parse it, and it parses it into DTO objects. Remember those DTOs we were just talking about? Here's where we see we can read just raw text data from the internet in JSON format and then create Java objects out of that and use those Java objects in our application. So that's plant DAO. Now we're also going to use Room database to persist locally on the device. And for that, once again, we simply need an interface. And Room, just like Retrofit, will figure out a class at runtime to implement that interface and take care of all of the nitty-gritty and the heavy lifting for us to actually do the persistence. It's quite straightforward. We also need a class that's just going to kind of bootstrap that Room database. We're calling the specimen database, and that's going to extend a class that we're going to import from an external library called Room Database. Now, a few other things that you might have noticed here, and I tried to grab a couple screen captures and zoom up on them, but arrows are important. So for a parent-child relationship, in Draw.io, it's typically a straight line with no arrowhead. If we're extending a class, just like you saw on our specimen database, extending Room Database, it's typically a solid open arrowhead at the superclass, and then a straight line down to the subclass. If we're using, one class is using another class, typically a dashed line with an arrow at the end. And then to implement an interface, we'll typically have a solid triangle at the interface, and then a dashed line down to the class that is implementing the interface. I will say I've seen a few different interpretations of these arrows in different tools. So in Argo UML, a tool I used for many years, it did use the same way of implements interface and the same way of one class extending another, but there was a solid line for use. The solid line was not for parent-child. So little difference between tools. I'm going to go ahead in this video and assume the Draw.io tools are the tools that I want to use. So let's jump right in. We can start our diagram simply by going to a browser and pointing it to draw.io. Now I'm going to choose Create New Diagram, and you notice that this is saving to GitHub, which is ideal because we're going to end up using this diagram in a design document, which we're going to host as a readme.md file in GitHub. If you don't see GitHub up there, or you want to save it somewhere else, simply hit here on Change Storage, and you see there's several options. I'll go ahead and stick with GitHub and then Create New Diagram. Now from here, I'm going to take a look at UML and scroll down a little bit, and we're going to do, let's do this diagram here because it's a class diagram and it shows some packages and the like. So I'm going to call this one myplantdiary.draw.io. That'll work just fine. It needs us to authorize GitHub, so I'm going to go ahead and choose Authorize. Now it wants me to put this into a repository. I'll put it into my plant diary queue. And I'll choose Authorize. And install. And then put in my super secret, super secure password. And now Draw.io is saved on my GitHub profile. Now one trick is if we go back to Draw.io now and we select our My Plant Diary queue, it will take us in and show us all the branches, and it won't let us choose OK until we select a branch. I could put it in master, but that feels kind of dirty. So what I'm going to do is go back to GitHub and create a new branch. Simply call it UML. Now let's go back to Draw.io, and I'm still in Plant Diary queue. I hit refresh, and Plant Diary queue, let's select that again, and sure enough, here's UML. Notice as soon as I click UML, it allows me to choose OK. Here again, I'm debating I probably should create a folder for it, but since I'm in my own branch, we'll go ahead and run with that. I'll choose OK. So yeah, OK, add my Plant Diary UML, and OK. And we see now it brings us up to this drawing pane where we can start to think about what our UML diagram is going to look like. It gives us a sample to work with, but let's go ahead and clean this up a little bit and start from scratch. Otherwise, it's going to be a little bit tricky. Now we essentially have a fresh page here. So what I can do now is grab a package like this, and we can think about the different packages that we're going to need in our application. Now, luckily I have a prior version of this with some finished product here where we can take a look at some of the packages. So we start with essentially our root package, and we have a couple items there, including a broadcast receiver and retrofit client instance and a few things like that. Then we have a UI package, a service package, a DTO package, and a DAO package, and also this one for background processes. So we'll keep it fairly simple to start with. Now, package name, you typically want to have a domain name in reverse, something that's unique. So I have reserved the domain name myplantdiary.com. So I could start it off with com.myplantdiary, And then we could put in a subpackage name like UI. You know, you can kind of move this label around a little bit. Maybe do it an unofficial way just by hitting enter. I know back at a tool I used to use, Argo UML, you could put the package name right up in the tab here, which is quite nice. But by moving it to the top, you get a little more space to cleanly put some classes, interfaces, and the like. So we start with this. I'm going to copy, and then I'm going to paste. Reason being, I'm going to have several similar packages. So we're going to have our UI package. We're also going to have a DTO package, and we can paste several times again. So we will do a DAO package and also a service package. Traditionally, the service has business logic, and that sits between the UI and the DAO. So I'm going to put this like this to make it a little bit easier to draw lines. And then the DTO is essentially data classes, and those data classes can traverse this entire hierarchy. So kind of best to put that here where it can be reached. So now let's consider the classes that we want to put into our packages. If we're using Jetpack Compose, then a lot of our user interface will be in essentially one activity, and it kind of obviates the need for having multiple activities, multiple fragments. You certainly can, and there are good reasons too, but a lot of times we're going to have all of our logic in one activity. So let's go ahead and simply call this one main activity. Now, we're going to get data from a series of view models. We're going to use view models and live data. Let's put those in the UI package as well. And the view model will typically come in two flavors. One that has a zero argument constructor, which is the easiest. Let's just call that one view model. And then another one that is going to need some information about the application itself, like the context. This is something that you'll need, for example, if you want to get GPS data. So I'll grab another one over here, and I'm going to call this application view model. Now, we could set up these fields as you see here. Not terribly important at this time, so I'll go ahead and just collapse those. I'm just deleting them. It'll be a little more important when we get to the DTOs because we're actually modeling things. Now, how do the view models get to the main activity? Well, we used to have this concept called view model providers. But now we can do a lot of that with Koin, which is dependency injection. And to set up Koin, we need to create something called app module. App module, where does that belong? Does that belong in UI? Maybe. But you know what? Let's go ahead and define one more package here. Let's call this one just the root package, which is where we're going to put our configuration for Koin. And we're also going to put our configuration for Retrofit and a few other things that are coming. Let's just call it com.myplantdiary because you see that, there we go. You see that that's essentially the root. It's the root package of all these other things here. So let's go ahead and add a class to this. And this is for Koin. So it's going to be called app module. So Koin dependency injection, that allows us to essentially define our view models and then make them available to main activity. And we can draw a line to indicate a relationship between the activity and the view model. In UML, I typically used a solid line to indicate this uses a relationship. But it's interesting in Draw.io, they're calling that parent-child, and instead they're using this dashed arrow to indicate use. So, okay, we're on Draw.io, we'll use their vernacular. So there we go, we have our use for the default view model, and then we'll do one more for the application view model. Just one moment as we drag this guy and drop him right there. Okay, wonderful. I won't bother drawing lines between Koin and the other things because it's kind of a given what Koin does. So there we go, we have our user interface, we have our view models, and we have Koin set up. Now, I hope that was fun, but let's not stop there. Sometimes I've seen class diagrams that essentially just do the user interface and don't consider anything else. It's important to consider the other packages as well, the DTO, the DAO, and the service package. Now, because the DTO is essentially a data holding class, or a noun class that goes from layer to layer being DAO service UI, let's go ahead and define that next, because that's going to help us to define our other layers as well. So we are putting together a plant diary application, or essentially an application where you can keep a journal of your plants. Now, we want to think about two different types of data that we're going to store. One is scientific data that we can say about all plants. So in other words, a Fuji apple tree, Malus domestica Fuji. So genus is Malus, species is domestica, cultivar is Fuji. Common name is Fuji apple. Fuji apple trees tend to grow about 25 feet tall, and they tend to have a life of about 20 years or so. That's something that we can say about all Fuji apple trees, and that's what we're going to call a plant. But what about a specific Fuji apple tree that I can touch? Well, we'll call that a specimen, because that has other data. It has latitude, it has longitude, it has a date when it was planted, and additionally it has a reference back to that initial plant record. So two DTOs we want to define, plant and specimen. Let's go ahead and grab this. You can think a little bit about this kind of like a database table, because that's where this is eventually going to be persisted. But we don't want to put this in the DAO layer, because this DTO layer does float across all the other layers. So let me grab a couple classes here. We'll call this one plant. And plant is going to have several fields. You see that we'll typically have the name of the field and then the type that follows. So plant ID would be an integer. We might have a genus, which would be a string. Species, also a string. Cultivar, a string. And common name, string. Obviously, we've overflown the box here, so let me see if I can get us a little bit more room. A little drag on this arrow, and there we go. Method, I'm not really going to worry about methods. DTOs only tend to have the traditional methods of toString, equals, hash code, and the like that come with Java-lang object, so that one's safe to go ahead and remove. Now, our other class we're going to call specimen. So specimen, once again, we're not going to worry too much about the methods because it is a DTO. We're going to pay more attention to the fields. Let me go ahead. This time I'll work a little bit in advance and try to buy us a little bit more space here. So here, let's start with the specimen ID, which will be an int. And let's also have a plant ID, which will be an int. That's essentially like a relation back to that plant master data record that we have up above. Then we're going to have longitude. I'm going to make that a string. And latitude. Make that a string as well. Why strings? Well, we have to keep in mind floating point arithmetic, which is weird in object-oriented programming languages. To put it in a short form, imagine 1 divided by 3, that's 0.3 continuous, but a computer doesn't have a way to represent continuous. So there's a bit of inaccuracy built in. Well, when you're dealing with latitude and longitude, those points to the right of the decimal are significant. So I find that sometimes it's better to save it as a string unless I'm actually doing some math on it. Okay, so we have our plant and our specimen. Now let's grab this parent-child association that Draw.io recommends. So I'm going to kind of grab one end and put it there, and then I'm going to grab the other end and put it here to indicate that relation between plant and specimen. And that wraps up our DTO, for now at least. Let's now take a look at the service layer. The service layer is a little bit tricky if you're new to programming or if you're writing a new program. Because what's a service layer? Well, it's business logic. What's business logic? That's a hard thing to put your mind around unless you have a good example. So I can give you a couple examples that I often use. One is a lot of video games. If you think about simulation games, you know, you put the train track here and you put the road there. How does that affect who moves into your neighborhood, something like that? That's essentially business logic. It's not persistence logic. It's not UI logic. It's business logic. It sits in the middle. Another good example I can think about from my days working in retail point of sale. This is probably one of the better examples of true business logic that I can think of. We know what buy one, get one is. Buy one, get one free. But what if it's buy one, get one free limit 4? Okay. Now, what if the customer has purchased 7 items? Of those 7, which ones are free? Well, that's business logic, determining which of those are free. because there again, it's not persistence. We're not saving to a data store, and it's not UI. It's just saying, here are the 7 qualifying items that the customer purchased. Buy one, get one free, limit 4. So let's say that would be 2 sets of buy one, get one. You're going to get 2 items free. So out of these 7, which are going to be free? The 2 that are the best benefit to the customer, or the 2 that are the best benefit to the retailer? That's essentially business logic. So another thing that business logic will do many times is aggregate data from multiple DAOs. So at this point in my service class, or my service package, I could have a plant service and a specimen service. Let's go ahead and say plant service. And then we'll make another one called specimen service. It's oftentimes a good idea to create an interface that these will implement as well for several reasons. Let's give ourselves a bit of room here. So we can call this one maybe interface iPlant service. And let's grab the implementation arrow here. This is kind of funny. The open arrowhead typically goes to the interface, and then the bottom of the arrow goes to the class that is implementing that interface. So a really good reason why we might want to use an interface is, we might want to make a stub class. So a stub class is like, we don't know what this full implementation is going to be just yet, but we can make a hard-coded implementation to fill in the gap. And that way our user interface person can continue to work as we are working out the details of what this class is actually going to do. So let's give ourselves a bit more room here, and I can fix that package later. But let me go ahead and grab another class, and we'll call this one Plant Service Stub. So stub class, just a hard-coded implementation, and it buys us a little bit of time and a little bit of ability to work in parallel when we're on a multiple developer project. So I'll tell you what, let me try to give us a little more room this way as well. Just so that we don't have so much overlap going on. That'll make it a little easier to visualize. So we'll bring our actual plant service here. And then pause the video for a moment just to tidy some things up there. So there we go. So let's do the same thing with specimen service. We have our specimen service and our specimen service stub. And we will tie them together with an interface. And once again, we'll use that implementation arrow to show that both of these classes implement the same interface. The value of that is polymorphism. Remember what polymorphism is. Polymorphism says the variable type tells you what methods you're allowed to call, and then the object type that is inside of that variable tells you what will actually happen when you call those methods. Now the value is, when we are looking at our view model, we don't have to tie it to these actual implementation classes. Instead, we can tie it to the interface itself. And that gives us the flexibility to use a different implementing class when needed. So you see I have a use arrow going from left to right there. And whoops, and we'll do one more. Again, from the view model to the service, and that's typically what we're going to see, is that the view model will refer to the service through its interface, and the view model will talk directly to the service. Typically, a view model will not talk directly to a DAO. So with a little bit of magic, and I can do a bit of rearranging here off camera, we should be in good shape there. So that is our service layer. Now let's take a look at the persistence layer, or the DAO layer. The DAO is going to have potentially 2 different things to do. One is retrofit, which we're going to use to parse JSON and consume that in our application. Almost all great applications today do some type of data integration, and that data integration is often in a JSON form. So think very seriously about how you'd like to integrate data and what data you'd want to integrate. And to integrate data, a really good way to do it is Retrofit, which is a library that we can use, and it's very straightforward. As a matter of fact, you remember what I was just saying about interfaces? Well, with Retrofit, that's essentially all we need. We need something called a Retrofit client instance, and then we need an interface where we simply define some methods. And Retrofit is able to essentially make a class at runtime that implements that interface. And that class will go out and fetch our JSON data and parse it into an object. What object will it parse it into? One of our DTOs, which is why it's so important to think of the whole picture here, not just an individual activity or an individual DTO, but how all of these things relate together. So let's go ahead and in our project, I'm going to grab the plant data from an online source. So all I need to do then for Retrofit is define the interface, and we'll simply call it iPlantDAO. Now, we'll likely need to add some methods to this at some point, but at this point, we're just kind of getting that idea across. So let's draw a line between our plant service and the plant DAO. And notice I'm going from the service, not the stub, because remember the stub is just a hard-coded implementation. But the actual implementation is where we're doing all the wiring and the integration. So there we go with that. Let's go back up to this root package that we have, and we need to define one more class for Retrofit, and we're simply going to call it Retrofit Client Instance. And this is where we say things like, what's the URL that we want to access? So once again, we'll kind of make that a small one. We just know it's there to get Retrofit started. So Retrofit, grabbing data from online and consuming it inside of our application. The next thing that we need is potentially Room database. So Room database will allow us to store data locally on the device itself, which is good for like offline reasons or things like that. So Room is very similar. For Room, all we need is an interface. Now our plant data we're fetching from online, but the specimen data is what we're recording with this app. So if I have a plant diary, then every plant that I chronicle, every tree that's in my yard or every flower that's in my yard is essentially a specimen. So that's the data that we're creating, which is why we want to be able to store that locally on our device and possibly sync it with something else like Firebase or something else later. So once again, for Room, we simply need an interface. It's really easy to do. And I'm going to call it iSpecimenDAO. Now, we will draw a use relationship between the specimen service, and again, the actual service, not the implementation. Or, I'm sorry, the actual service, not the stub. Remember, the stub is just hard-coded implementation of that interface. So we'll draw a line between the specimen service and this DAO. Also, just like Retrofit, we need a class for this database, something that just does the setup for it. So I'll tell you what, I'll keep that class here in the DAO because it is pretty closely tied to this DAO here. So we'll keep it in the DAO package, and we'll just call it Specimen Database. And we'll go ahead and collapse these. Now, if we want to, we can show another relationship here, which is Specimen Database has to extend a class that's provided to us in a library, and that class is called Room Database. The Room Database is from an external library. I'm not going to put it in one of our traditional packages. However, I will keep it out here, and then I'm going to do an extends relationship. So extends is a superclass subclass relationship, and typically the open arrowhead goes to the superclass, and the bottom of the arrow goes to the class, which is the subclass of the superclass. So an extends relationship will look like this. You can certainly extend classes within your own packages and within your own program. This is a good way to represent how we're extending something external as well. One correction here I noticed after I finished recording that segment is actually Specimen Database is what extends from Room Database. The interface does not have a relationship with that Room Database. So here is the updated version and what that arrow should look like. As a matter of fact, our activity class is going to extend from activity. We could represent that if we wanted to. So there are a couple of other relationships that we're going to want. So now we have our completed class diagram, and we've integrated Jetpack Compose, our ViewModels. And by the way, the ViewModel is where we're also going to integrate Firebase Firestore for syncing online, offline. That's typically closely related to that ViewModel, and it essentially is taking care of that entire stack of persistence for you, and also the stack of synchronization across devices. So it's definitely a very valuable framework. So that will be in the ViewModel. Then we have our DTOs that float across layers. Then we have our service layer for business logic. And then we have our DAO, where we're doing both Retrofit to grab data from online and consume it in our app, and also Room database to store data locally on our device if we wish. Now, not every app will use every one of these technologies, but a lot of apps will use many of them. So it's great to get experience with each of these different technology stacks. With all that being said, let's go ahead and save. We'll call it My Plant Diary class diagram. Now, if we take a look at GitHub, what do we see? Now, this is interesting. Our UML branch had pushes less than a minute ago. And if we take a look down here, we see My Plant Diary class diagram, and it has the XML source for this. Let's go back to Draw.io, and I'm going to choose a Save As this time. And let's save it as, do a PNG file. And once again, we'll choose GitHub, and we'll say My Plant Diary PNG, and OK. Once again, we'll select our folder, My Plant Diary Q, and then we'll go to the UML branch and choose OK. And let's go back again and take a look at that UML branch. And sure enough, what do we see? myplantdiary.drawio.png. Right-click and open this in a new tab and take a look. Hopefully this looks somewhat familiar. This is the class diagram that we came up with. Now that it is hosted in GitHub, it's going to be really easy to integrate this into a readme.md and make a design doc out of it. So in this video, we covered quite a bit about class diagrams and also the different components that we'll see in a typical Android application and how to model those on the class diagram. So design up front is important because it makes sure that you make the best use of your time. So I encourage you to experiment with class diagrams like this before actually jumping in and writing code. And as always, I hope this video has been helpful. Thank you.